Right now, the entire AI industry is obsessed with a massive illusion. We watch a vision language model look at an image, and we get mesmerized when it describes it to us. We give it a picture of a crowded desk, and it says, "There is a ceramic mug next to a laptop." And we go, wow. It can see. Except, it can't. Not really. Describing a room is not the same thing as navigating it. If you ask a standard AI model, "Great, now pick up the mug," or "Click the submit button on that website," it completely falls apart. Why? Because most AI models today are essentially poets. They are incredibly good at words, but they have absolutely no spatial awareness. They treat geometry like a spelling bee. But last week, NVIDIA dropped a model called LocateAnything, and it proves that while everyone else is trying to build AI that talks about the world, NVIDIA is quietly building the infrastructure for AI that interacts with the world. This isn't just another incremental update. It is a fundamental rethink of how machines map human language to physical and digital space. And today, we're doing a complete technical autopsy on how it works, why the way AI currently sees is fundamentally broken, and the terrifyingly massive dataset NVIDIA just weaponized to fix it. To understand why LocateAnything is a big deal, you first have to understand the massive hidden flaw inside almost every vision language model on the market right now, from GPT-4o to QuenVL. When these models want to point to something in an image, they use what's called a bounding box. It's just 4 coordinates. x1 y1 for the top left corner, and x y2 for the bottom right corner. Simple, right? Here's the catch. Because these models are built on standard transformer architectures, they treat those coordinates exactly like they treat words in a sentence. They use next-token prediction. That means the AI has to predict x1. Then it stops, looks at x1 and predicts y1. Then it stops again, looks at both, and predicts ax2. It is serializing 2D space into a 1D line of text. Now imagine you're a robotics agent, or a computer use agent trying to click a button on a moving screen. If you have to wait for the model to slowly read out 4 separate text tokens just to find one button, you're already too late. Even worse, it causes massive geometric corruption. If the model gets a little distracted and miscalculates y1 by even a few pixels, the rest of the sequence is ruined. The entire bounding box breaks down because the later numbers depend on a broken foundation. It's slow, it's brittle, and honestly, it's a terrible way to navigate reality. So, what did NVIDIA do? They looked at this bottleneck and said, what if we stop treating space like language? Instead of predicting coordinates 1 token at a time, NVIDIA introduced something called parallel box decoding, or PBD. With parallel box decoding, the model predicts the entire bounding box as a single atomic spatial unit. In one single step, it outputs the whole coordinate block. Think of it like this. Instead of carefully drawing a square by drawing line 1, then line 2, then line 3, then line 4, NVIDIA just stamps the entire square onto the canvas in a fraction of a millisecond. The result? LocateAnything runs up to 10 times faster than traditional autoregressive models. And because it treats the box as a single object rather than 4 separate predictions, the geometric consistency is beautiful. Even in dense, cluttered, chaotic images, the boundaries don't warp. But engineering in the real world is never that simple. If you force a model to always guess everything in parallel, what happens when an image is genuinely confusing? What if 2 buttons are overlapping, or text is blurry? Well, NVIDIA's engineers built a brilliant safety valve into the architecture, the tri-mode engine. LocateAnything doesn't just have 1 gear, it has 3. First, you have fast mode. This is pure multi-token prediction. It blasts out the entire bounding box in parallel. It is built for raw, unadulterated speed. If you are running an on-device robotics loop, or an AI agent that needs to navigate a website at lightning speed, this is what you use. Then, you have slow mode. This falls back to the traditional token-by-token auto-regressive generation. Why would you want this? Because it's highly conservative and stable. It's perfect for offline tasks, like building massive datasets where you don't care about speed, you just care about absolute precision. But the magic happens in hybrid mode, which is the default engine. When LocateAnything is running in hybrid mode, it starts every single task in fast mode. It assumes it can hit the speed jackpot, but the moment it detects layout ambiguity, overlapping objects, or formatting violations, it instantly and dynamically switches to slow mode for that specific target. It keeps 90% of the speed gains of parallel processing, but keeps a safety net in its back pocket so the AI never completely hallucinates a coordinate. It's an incredibly elegant piece of engineering triage. Now, an elegant architecture is useless without data, and NVIDIA didn't just build a model, they built a monster of a dataset called LocateAnything data. Look at these numbers: 12 million images, 138 million natural language queries, and nearly 800 million bounding boxes. But don't let the big numbers distract you from what NVIDIA is actually feeding this thing. When you look at the distribution of the data, you can see exactly what NVIDIA is planning for the next 3 to 5 years. Yes, about 67% of it is general object detection, teaching the model what a chair, a car, or a coffee cup looks like. But look at the rest. Over 16% of this massive dataset is exclusively dedicated to GUI element grounding. That means parsing desktop screens, mobile apps, software menus, and web pages. Another chunk is pure OCR, document layout understanding, and point localization. NVIDIA didn't build this to help you sort your vacation photos. They built this because they know the next multi-billion-dollar AI frontier isn't text generation. It's large world models. It's computer use agents that can log into your Salesforce, navigate a chaotic enterprise UI, find the unformatted invoice total in a chaotic PDF, and click the right button without a human ever touching a mouse. Now, we need to address some of the hype online, because a lot of people are fundamentally misunderstanding what this is. I've seen people saying, "Oh, it runs so fast. This is going to replace specialized object detectors like YOLO. Let's squash that right now." No, it won't. If you are building a self-driving car or a factory conveyor belt that needs to detect a specific fixed class of objects, like a human, a box, or a stop sign, at 300 frames per second directly on an edge chip, you're still using YOLO. YOLO is hard-coded, hardware native, and blistering fast for fixed tasks. LocateAnything is an open vocabulary grounding model. It's built on a massive Qwen 2.5 backbone. It understands complex human language and spatial context simultaneously. YOLO can find a generic cup. LocateAnything can find the blue coffee mug with the chipped handle that looks like it belongs to a software engineer. It bridges the gap between how humans talk and how computers locate pixels. They are completely different beasts. Here is the ultimate takeaway, the macro trend that everyone is missing. Most AI companies right now are locked in a brutal, expensive war to make models describe the world better. They want higher benchmarks on text, better poetry, and prettier imagery. NVIDIA does not care about that war. NVIDIA is focused on making models interact with the world better. By taking the core foundation of a vision model and replacing slow, text-based coordinate generation with high-throughput, parallel geometric decoding, they are laying the plumbing for the entire physical and digital agent economy. Whether that agent is a piece of software clicking buttons on a desktop, an AR headset guiding a surgeon, or a humanoid robot reaching for a tool on a cluttered workbench, they all need to answer one fundamental question before they can do anything else. Where is the specific thing I need to interact with? With LocateAnything, NVIDIA didn't just answer that question. They made the answer instantaneous. Let me know in the comments below. Are you more excited for digital computer use agents or physical robotics taking advantage of this architecture? Hit subscribe if you want more technical autopsies that bypass the hype, and I'll see you in the next one.